Okay, calculus, here we go. We're going to be looking at AB25 Riemann sums, and that's how you say this word Riemann, however you want to spell it, but this is the guy, Riemann. He kind of created this method, this procedure for trying to find estimating sums of areas under curves, because that's the theme we're going with. We got a curve, we want the area under it, so we're going to split it up, add it up, and find that sum. So let's start with this first example. We're just looking at this curve. There's area between it, and we're looking at, let's say, from here to here, from 1 till about, let's see, this would be 1, 2, 3, 4, 5. So from 1 to 5. Now, as we're trying to see what these boxes that we're going to make look like, so far we've done right rectangles, but now we're also going to be looking at left, we're going to be looking at trapezoids, and we're also going to be looking at midpoint. Not left, right, not right, but right in the middle. So the first couple right rectangles, notice that the top right corner of every box is touching that line. So you would start going to the line and then actually draw to the left. So then the left rectangles are going to have the top left corner of each box touching that line, and we're still splitting it up. This is still from 1 to 5. Going 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We're trying to add these boxes together. And then midpoint and trapezoids are a little bit different. The midpoint doesn't take the right, it doesn't take the left, it takes the one right here in the middle and then goes each way. Same thing for all the other points here. It's that midpoint. And what that does, and some people think that that has some balance to it as opposed to the left and right, is we have a little bit of area outside the box and a little bit of area inside the box. It's kind of like you're balancing out your underestimate and overestimate. Trapezoids here, this is the where we just make a trapezoid. Remember, a trapezoid has two lines parallel, and it's got this other edge, these other edges here. So we're trying to add these trapezoids. So for example, the first trapezoid is here, this being outlined in red. And then we could do the second one. I'll outline that one in blue. We can alternate, and you can see how we're making trapezoids as well. So we got different shapes, different geometric shapes that can estimate this area under the curve. Something to keep in mind, we're going to come back to this later, but the area of just one trapezoid, so the area of a trapezoid, that is equal to, there's a formula for it, 1/2 the sum of the bases, base 1 plus base 2 times the height. Now this is actually kind of backwards, or not backwards, but inverted here, because we're used to our trapezoids being the parallel bases are horizontal. That's more common format of seeing this. And then the height is that distance between them. So right here, that means our base 1 and our base 2 would be these two lines there, the two vertical lines. And then the height would actually be this line that goes between them, the width that we would say. Okay, so that's just a quick review of trapezoids, because that is going to come up in a minute here. Okay, so we want to calculate area of x squared minus 3. And we're going to use 8 rectangles or trapezoids. We're going to start out with doing the rectangles, and we're going to need a lot of work here. So if you need to pause the video and get some extra scratch paper, that would probably be a good idea. And I'm going to kind of work through it maybe slightly different than you would expect. I'm going to be doing a lot of extra work, not a shortcut formula, because I really want you to see where each area comes from. So let's do a couple things. First, let's open up our calculator. Mine's warming up here. You should get yours out as well. And we're going to first put in that function, x squared minus 3. Now our interval is from 2 to 6. If you didn't see that, it's actually covering up my screen here. But from 2 to 6. And for x squared minus 3, we know that 2 squared minus 3 is real 4 minus 3. So that's y equals 1. And then for 6 squared for the upper end of the curve up here, the top right corner, 6 squared minus 3 is 36, minus 3, that's 33. So our y range needs to go from 1 to 33, and our x range needs to go from 2 to 6. So let's get that done in our calculator. So we go to y equals, we've got some other functions here from previous ones. I'm going to clear these out. We have x squared minus 3, so x squared minus 3. So here's what I got typed in there. For my window, I want to change it. 4 to 6 is not what we're looking for. We're looking for 2 to 6. And our y range, it looks like we're going from about 0 to 33. Well, let's say 36, just to give us a little bit extra space. And let's, for our y scale, just for cleanliness, I'm going to count by 2's. Just to make it look a little cleaner. So now, let's graph that. Alright, so we have a curve. It actually looks quite a bit like the other one that's already on the screen, if you see that. The difference is I counted by 2's. That's why I only got so many dots here, but he has a lot more. So we didn't have to do that, but I really like seeing where we're finding this area from. So what I'm going to do, I'm going to copy and paste this onto a new window. Now I'm going to do right rectangles, 8 of them. So let's copy, we're going to move this not to that page but to a new page, insert page after, there we go. Okay, so we're starting with this. Let's just do the left and the right. We'll do these in red and blue, which means I should probably duplicate this picture. So we'll duplicate it here. Is that duplicating? Yeah, there it goes. Now I got 2 of them. So we'll start with, how about right is red? Because they both start with the letter R. So we're going to do right boxes first. So if we need to do 8 of them, notice that I got 1, 2, 3, 4 dots sections here. So I'm going to split each of those in half. And that means that each box here is going to be 0.5 wide. So we're going to have box 1, box 2, box 3, box 4, and then box, we could even call this right box, RB, 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 RB. And we got some more, RB5, RB6, RB7, and RB8. So the first right box is going to be this tall. Go across. And we're looking for the height of that. And notice I had to go, we start out here at 4. Not at 4, at 2. And then we're at 2.5. Let's make this slightly smaller. Then we're going to have it 3. And we got 4, and then 5, and then 6. And each of those marks in the middle is actually half. So the height of that, if we plug it into the curve, because this dot right here, this dot is at 3 and then f of 3. So we got to figure out what that area is going to be. And remember, I don't know if you remember this, but we did do this using our table to calculate them. And we're going to bring that up here in a second. So let's start with the first box. We're always doing the area of a box. It's going to be, our width times our height, and that's, in this case, our width for each one is 0.5 because it goes from 2 to 2.5, 2.5 to 3, and so on. But our height is going to be some type of f of something. So for the first box, that width is 0.5 from 2 to 2.5. But the height is right here for the first one. That's f of 2.5. So it's going to be f of 2.5. Then for the second box, that's going to be 0.5 times f of, now we're skipping over 0.5, now we're doing to the next one, which is at 3, f of 3. So that's going to be f of 3. And then for the next box, we have 0.5 and f of 3.5. And we got all these things where we got to figure out, oh, I got more space here than I was thinking. Or we got to figure out what is f of 2, f of 2.5, and so on. So that's going to help us if we were to fill out this table here. Down here. Now it says f of xi. So I'm actually going to change these a little bit just for purpose of what we're looking at. I'm going to call this at 2. So x sub I, oh, here's where it goes. So this is 2, then 2.5, then 3, and 3.5, 4, 4.5, 5, 5.5, and 6. That's where those pieces are coming from. So what is f of 2, f of 2.5, and so on? We go back to our calculator. We want to use our table, but I want to set it up so it's perfectly set up for what we need. We're going to start out at 4, not at 4, at 2. And we're going to count by 0.5s. So now when I go to my table, f of 2 is 1, f of 2.5 is 3.25, and so on. So I'm going to drag and drop this onto the screen, shrink it down a little bit so it doesn't take up all the space. Whoops, we need the arrow. Here we go. So now I can just write down some of these answers. We got f of 2 is 1, and then 3.25, and then 6, 9.25, 13, 17.25, 22. And we need 2 more answers, so let's go back and look at our calculator. Scroll down a little bit. 27.25 and 33. 27.25 and 33. All right. So now, what are we going to try and do with that information? We can get rid of this and get rid of this. There we go. So the base that we were using for each of these, I didn't fill it in yet, but it is 0.5. Now if we're doing right boxes, that means that it's going to be 2, or the width, 0.5. The first right box was 0.5 times f of 2.5, which in this case is 3.25. And then after that we can see what each of the additional areas is. Now we did a shortcut with this before, so we're going to pull up our calculator again. And all we're going to do in our y equals is we're going to take our width, which in this case is 0.5. Let's put that in as y2. I'm going to turn it off. And if I multiply those two together, that'll get me that area product that we were looking for. So we're going to take y2 times y3. So now we're going to look at, well, I suppose we can leave this turned on. That's fine. y2 times y3. So we got to go to vars, yvars function, and now we're doing, or no, it's y1 times y2. Vars, yvars functions times y2. So what this is doing is it's doing that area, that width times the height. So when I look at my table, I got to scroll over to get to the ones that I want, y3 right here. I'm multiplying those two numbers together that we were looking at. I got to scroll up all the way to start at 2. There we go. So it's going to be 0.5 for the first one, then 1.625, and 3, and so on, and so on, and so on. So let's go ahead and take this, copy and paste it onto the new page, and then you guys can pause the video if you need to copy it down. So that's going to shortcut all the stuff that I was doing up here in red. So I can erase all that. Because we're using our calculator here to kind of shortcut things. So we go back to our calculator, drag this in over here, make it a little bit smaller. Then we have a couple more numbers missing, so I'll get those as well for you guys to see. 5.5 and 6. And there were those numbers there. All right. So now what we have all these numbers, 0.5, 1.625, 0.3, all these. These are our areas. So this is the area of the first box, and then the second, and then the third, and so on. 5, 6, 7, 8. No, how many do we have here? 1, 2, 3, 4, 5, 6, 7. We got 7 there, and then we need the 8th one. But the problem was the first box that we were doing, I don't know if you guys caught this, didn't start at 2. It started here at 2.5. So for those ones, those are the right ones. Now if I were to copy and paste these same two tables, I get to use them again. Let's duplicate it. There we go. For the left box, it's going to use similar numbers but slightly different. So let's see what happens with those. Let's move this out of the way real quick. Okay, so what's going to happen with those is if when I'm doing left box, let's just start here by splitting it up. We need a blue pen. The left box is going to use that top left corner. So for the last box here, this height is going to be f of 5.5. And the first one is actually going to be here at 0. The first height is going to be f of 0. So we're going to be doing, or not 0, f of 2, pardon me. So all these blue ones that I'm highlighting, 3, we went 4.55 and 5.5. We end there. So for the right sums, we're not going to be using the last one. And for the left sums, pardon me, we're not going to be using the last one. For the right sums, we're not going to be using the first one. Alright, so what are we trying to do here? We're trying to actually add up all these numbers. So I could calculate that. I have a calculator. There are shortcuts to do it, but let me go ahead and just do it with my calculator. So if I shrink this down, let's just find the sum of things. So we're going to clear this graph, clear. So we just need to add 1.625 plus 3 plus 4.625, oops, 4.625 plus 6.5 plus 8.625 plus 11, and then we got plus 2 more items, 13.625 and plus 16.5. So we add all those numbers up, what do we get? So for the red sum, we get 65.5. Now let's do the blue ones. Now if you're thinking about it, the blue ones are very similar, except we don't include the 16.5. So I'm going to press second and then enter, and that'll re-enter everything I typed in. But I'm going to delete this 16.5. But we do need to include that first one, which is just 0.5. So I'll put plus 0.5, because that one was not counted in the reds. We're doing the blues here. Oh, let's go to, oh, we got a double plus sign. 49.5. So our two answers, oh, we didn't even see the last one. What was it? You guys probably remember by going back to it, but I'm going to go ahead and re-enter what we need here. Plus, it should be that plus second entry, plus 16. There should be a difference of 16. Okay, 65.5. So we have 65.5 and 49.5. So up here in the red, the total is 65.5. And down here for the blue, it's going to be 49.5. So those are our two areas. So that gives us the answer to the first one that we're looking at here. So the right rectangle gives us 65.5. Let's do that in red like we were doing before. 65.5. The left rectangle gives us 49.5. And the trapezoid, now we didn't do trapezoids yet, but we can figure that out. And then we haven't done the midpoint formula. But that's going to be not too hard either. We just need to figure out the midpoints of each of those numbers. So let's start out with the trapezoid formula. So for a trapezoid, that means we have to find the area of the first trapezoid, and the area of each trapezoid is 1/2, and then we got the two bases, which is really our two heights, f of x sub I, and then our f of x of A and f of x sub B. And then times our height, which in this case is our width. Well, we know that the first width, and like any other width, is going to be 0.5. And we got this 1/2. So we just got to figure out what those two heights are. And we're going to be copying this formula and adding them all up. We got to do it how many times? We got 8 trapezoids. So this is probably one of the more tedious ones, but that's okay. We're just calculating. So for the first one, we got to have the two heights of that picture. So let's go back and look at that picture real quick. So here it is. Let's copy and paste it again. There's our picture. So for this height, for the first one, remember we split this up into 8 boxes. Or in this case, trapezoids, I should say, not boxes. And for each of these heights, for example, this first one has 2 heights. It's going to be f of 2 and f of 2.5. And then for the second one, so that's the first one, for the second one, it's going to be f of 2.5 and f of 3. And then for the third one, we're going to have f of 3 and 3.5. So we kind of copy and paste these numbers. So the first one is really f of 2 and f of 3, or 2.5. Those are our two heights. But then for the next box, we have f of 2.5 and f of 3. And then we got f of 3 and f of 3.5. We got to work our way all the way up until we get to here, f of 5.5 and f of 6. And f of 4 and f of 4.5. F of 4.5 and 5. So it looks like we got a couple more. 1/2. F of 5 and f of 5.5. We got f of 5.5 and 6. All right, now we're done. So this is a lot of calculation. you're going to have to go back through and plug these numbers in. I'm going to go through and do that right now. I'm going to pause the video, but then you guys can plug in the numbers and check them for yourselves. So I'm going to pause. I'll see you in just a couple seconds here on the video, but you guys got to go through and substitute those values and see what you get. Alright, so here we are back with these numbers that are filled in. And just to show you kind of the shortcut I did, I used the y1 function and I moved that 0.5 and that 1/2 together. So I did 0.5 times 0.5. And then I did y1, which is the same thing as like f as a function. And then plugged in the numbers and then just kept repeating that same entry by pressing second and then enter. And then it repeats the entry and I just have to change the numbers. So I came up with all these values. And now I just need to add them up through the magic of television here. Not really television, YouTube videos. So we're going to do 1.0625 plus 2.3125 plus 3.8125 plus, what's next? 5.5625, 5.5625 plus 7.5625 plus 9.8125 plus 12.3125 plus 15.0625. So I add up all those numbers and what do we get? 57.5, which sounds about right because that's the total is 57.5. That sounds about right because when we were looking at this, we were getting numbers around 65, 49, and then we got 57.5. Now the midpoint formula is the last one. We're going to end with that with this video just to get you guys going. And for the midpoint formula, this is where it gets a little bit interesting because we're not really looking for the numbers that we were with the left and right box. Here with the left and right box, as these come up, we have 2 and 2.5, but what we want is a number that's in between each of these. So let's try and come up with that number and then multiply it by 0.5 and find the area. So I'm going to insert another, and you can do this the way that it lists here on the calculator through this whole method here, but I don't really need to do that. It says the calculator can generate this chart. This is doing it with right triangles. We can adjust it for left triangles so you can make those charts, but we really want to do the midpoint. So I want to look at how to do this with a midpoint. So I'm going to do just like before. So here's our table. But we need to figure out what values do we need for our x. It's not the left side of the box, it's not the right side of the box at 2.5 or 2. It's right in the middle. So how do we mean that? Let's draw a graph. We gotta go back to our y equals and turn off these other ones. So we're gonna turn off that and turn off this. There we go. So here's our graph. We're gonna copy and paste this in here again. Let's insert page after. Okay, again, this is really good to be doing kind of like on another piece of paper. If you have this graph paper works excellent because then you can actually graph it pretty well. So we're going to do midpoint. Let's do purple. It's not left, it's not right, it's in the middle. So we still have our 8 boxes. Make this a little bit thicker for ourselves. So here's our 8 boxes in here. We got 1, 2, 3, 4, 5, 6, 7, 8. So now we want to cut across that middle of the box. And this first height right here, it's not f of 2, it's not f of 2.5, it's right in the middle between those two, which is going to be f of 2.25. Then the next one is going to be between 2.5 and 3, which is at f of 2.75. Then the next one after that is going to be f of 3.25. So if you're watching the pattern, we start at 2.25 and then we're going up by 0.5. So all I need to do to adjust my table then is instead of starting at 2, I'm going to start at 2.25. Now when I look at my table, x is 2.25, there's my y1, and we've turned off our other values, but let's turn that one back on just so we see what it was. We'll turn y3 back on by pressing enter on the equal sign there. Now when I look at my table, I have these areas, again, these helpful areas. Now we don't have all of them here, so we need to scroll down and get some of the other ones as well. We went up to 5.25, but we got to get all the way up to 5.75, so we need this last number in here too, which is 15.031. So that's the at 5.75. Then we got to add up all those numbers, just like we added up the areas before. So again, let's use our calculator. We go to our graph, we can clear these, and we're going to add these up. 1.0313 plus 2.2813 plus 3.7813 plus 5.5313 plus 7.5313 plus 9.7813 and plus 12.281. And the last one is 15.031. So we add all those numbers up and we get 57.2498. So the total is 57.2498. And that sounds appropriate. So we found all these answers, and this is just kind of practicing with adding up numbers and stuff. But now we're going to actually apply these in the second part of this video. So I'm going to stop the video here just to get you guys going on adding up the numbers and such. But 57.2498. 57.2498. And then we will look at some example problems. For example, we're going to look at this one in part 2. So pause it, try to catch up on filling in those numbers, but really focus on part 2. That's going to be way more important than part 1. Part 1 is just trying to get a little bit of familiarity with the process.